Hello, this is Dr. John, your physics and math professor, with another circular motion problem. This one is extremely similar to the previous one. If you haven't seen that one, go back and watch that one. Here we have a car of mass 925 kilograms going around a radius of, like this, 72 meters with a velocity 25 meters per second. But in this case, what we're asked to calculate is the coefficient of friction that will help to keep the car on the road. So here we have the car, it's going this way, and then it turns to go in this direction. What you're going to need to do is you're going to need to provide a force in this direction that's going to help to keep you on the road. And I'm going to draw up the different forces here on this little diagram, and I'll move some of these things up here to this side so that we still have them handy. Okay, I've come back, I've moved the centripetal or centripetal force over here, mv squared over r, and I've drawn a couple of diagrams that show you different forces acting on this car. Remember, this car is going on this flat road here, and it has a downward force of gravity of mg, an upward force of the normal force. Just going to write a couple of those things up here. Now in this case, since the road is completely flat and the road doesn't buckle up, it doesn't squeeze downward, this is going to have to be equal to that. So the normal force is going to have to be equal to mg. In this specific case, if the road is banked, there may be other things that come into play, but in this case, that's equal. And then I wrote this with dashed green line here, this centripetal or centripetal force that has to act in this direction. Why does it have to? Because it's going to have to keep you on the road, because you have this stress or force or inertia, because the car is going to want to sort of keep going. That's going to want to push you off. We call that the centrifugal force. That's going to want to push you off in this direction. So we have to create this force over here that goes in this direction. Now the centripetal or centripetal force is not an actual force in itself. It has this value that you're going to have to create, mv squared over r, but there's going to have to be another force or something that has to create this value. In this case, what is that? Well, I think you may know that that is the force of friction. So I'm going to draw that in here with red because friction is very painful. And that we'll call F, little f, force of friction. It's going to go in that direction, and the force of friction, the red one, is going to be equal to the green one. I'm going to draw those up here and write up what those are. The force of friction, you may have learned this in some of your other classes. The force of friction in all of these places where we have a normal force, the force of friction that is sort of in line with the surface, like in this direction, is going to be equal to the coefficient of friction between the tires and the road times the normal force. Whatever the normal force is, you have to multiply that by mu. Mu is a Greek letter, small letter m in Greek. It has no units. It doesn't have meters per second or newtons or anything, because this is a force and this is a force. If you're multiplying that by something with units, you would change the units of this force. So this is just a number like the number 5. And actually in the coefficient of friction is practically always between 0 and 1. For something like ice, an icy surface, it might be 0.1. For something like gravel, or for this, it might be 0.6 or 0.7 or something like that. But if you calculate it and you find mu, the coefficient of friction, to not be between 0 and 1, you've probably made a math mistake. Go back and check your work. So the force of friction is going to be equal to this. Normal force is equal to this. We have a lot of things that we're going to need, except what we need to also realize is that the force of friction has to equal the force here, the centripetal force going in this direction. And you just make those things equal and you'll find out how big the force of friction has to be. Here's the force of friction. So since, maybe I should change colors for that, the force of friction is going to be equal to mu times the normal force, which is going to have to equal this. Because that's the amount of force you're going to have to create with friction to move it in this direction and accelerate it toward the radius of curvature here. So let's make this equal to this, mv squared over r. We're looking for the coefficient of friction, that's mu here. We don't have to have this extra stuff here. And the normal force, remember we said the normal force is mg, so we can write that in there. I just might need to make some space. Let me do that. So it's mu times mg. Now if you notice carefully, you'll have an m here and an m here. We can cancel those two m's. And this g here, we can divide both sides by g, like this. That'll cancel the g, and we can put a g here. Now what do we have? We have mu is equal to v squared over rg. I'm going to write that up here so we have that handy. Mu is equal to V squared over RG. Make that square a little neater. And we'll plug in these numbers in a second. There's just one more thing I wanted to show you, just to help you to understand these problems, the physical problem a little bit better. Let's say we took this road here and we just cut this somewhere. We just magically, we had a little knife there and we cut that and we wanted to observe the car. So we're going to observe this car here. Here's the road. And this is right here where this cut is. And we have this car right on top of the road there. And what we're doing is we're sort of looking at the car and saying, let's create a new coordinate system for this car. One of the parts of the coordinate is going to be coming out from the road. That's going to be the normal force, hence in this direction, like this. That's coming out from the road. That's going to have to equal this mg that's going down. And then also we're going to have a force of friction that goes inward, like this. Force of friction. And the car, what will the car feel? If the car is sitting right there, it's going to feel like it's being pushed in this direction. Remember we talked about the centrifugal force, and that would be this one right here. I'm going to call that Fc, which happens to have the same value here. Fc is equal to m v squared over r. That's the centripetal toward the center acceleration, but that's also the same value that you have over here. So if you freeze this right there, you would just freeze the spot. You would have to realize, even though you have sort of a circular coordinate system here, that the up and down forces have to be balanced because the road's not buckling this way, it's not being squeezed, and the car's not going off this way into the bushes, and it's not being pulled in this way by the force of friction. So that means this inner force and this outer force have to be equal, and the up and down forces have to be equal. That's another way of looking at this, a balance of forces. The other way to look at it is to say that the force of friction is causing an acceleration, a centripetal acceleration toward the center like this. Both ways are valid, whichever way helps you to think about this problem better. Now let's just go and just plug these numbers in. All right, I punched the numbers in here. The velocity is 25, and we square it. The radius of the road, the radius of curvature here is 72, and g is 9.8. So I'm getting on my calculator 0.885. Now let's check for significant figures. Here we have 2, here we have 2, here we have 3. So let's go with 2. So I'm going to make this as 0.89. So mu, the way you would answer the question is you would say the coefficient of friction is 0.89. Remember, you do not put any units behind there. It's unitless. It's just a number like the number 5 or something, because we realize that we have the force of friction, which equals the normal force times mu. This is a newtons. This is in newtons. So you can't have any units on mu, or you're going to change one of these forces, or one of the two forces. So this is just a unitless number. So this is the answer. Hope that helps. If it did, check out my next video. Bye-bye.